Hello, good morning everyone. Today we will see 8051 interrupts. 8051 interrupts are basically used for interfacing many of the IO devices. There are two types of the interrupts in 8051, that is external as well as internal, or you can also categorize it as software and hardware interrupts. Now, apart from the interrupts, there are two methods are used in interfacing. One is interrupt, another is polling. So polling is a method used to monitor the IO requirements or maybe the IO signals one after the another serially in a time schedule, where interrupt is not time scheduled. So difference between the interrupt and polling. If you see the interrupt is actually it's a signal which is externally given, or it could be an internal software bit which will enable the interrupt. That is called as a set of the program which is executed on activation and interrupt, which is called as interrupt service routine. So interrupt service routine is nothing but a program that executed whenever an interrupt is activated. If you see the polling is actually done continuously. It monitors the status of the given device. So whenever the device meets that condition, it will perform certain job. So there is no such routine actually used for an polling. So it's nothing but you serve the device one after other whenever there is a need. Polling method is not so efficient, but however, most of the simple tasks can be fulfilled with the help of a polling. Whereas in polling method actually wastes much of the time of the microcontroller, because each device needs to be monitored even though there is no request. So that is the only disadvantage of the polling. Whereas interrupt is not like that. Interrupt will come only when there is a need. So if there are n number of devices, an n number of the devices will be monitored sequentially in case of polling, whereas interrupt is not the case. The interrupt will be served whenever there is a request of an interrupt to the controller, then only that device program, the interrupt service routine, will be executed. In other way, the interrupt we can assign the priority. So out of n devices, whichever the device needs the highest priority, only that can be served first. So rest of the lower priority can be served later. Whereas this cannot be done using the polling. Polling has to be performed sequentially. We cannot randomize it. Whereas interrupt is not like that. So if the request of any service comes together, then the priority will decide which is to be served. This is one of the very good advantage of using an interrupt. So diagrammatically, if you want to see how the program execution happens without the interrupt, the diagram which shows in the time scale, it executes sequentially all the tasks. In another case where the main program, whenever the interrupt comes, it goes to the interrupt service routine and it comes back to the main program after the return. So again, and another device requests for an interrupt, it goes to the interrupt service routine and it comes back to the main program upon executing the return. So this process will continue further. In 8051 microcontroller, there are 6 interrupts. So first interrupt is a reset. So reset is generally can be treated as an interrupt, even though there is no return, there is no interrupt service routine, but the mechanism is similar to an interrupt. Apart from this, there are 5 more interrupts which is purely regarded as an interrupt, that is two interrupts for the timers. 8051 contain two timers, timer 0 and timer 1. When the timer 0 and timer 1 overflows, you can activate a separate interrupt. They are the two interrupts. Another two interrupts called as hardware interrupts, which are separately mapped to an IO pin, that is port 3.2 and port 3.3, are the external hardware interrupts, which are named as INT0 or external 1 or INT1 or external 2. Now these two interrupts, external interrupts, can be used for any general purpose operation. Then the last interrupt, which is a serial communication interrupt. Actually this interrupt is a single interrupt that belongs to both receive as well as transmit. So you can generate an interrupt after the completion of a character sent serially, as well as you can receive interrupt can be raised for to receive the next byte. So this can also be done using the same interrupt service routine. In 8051 we can configure any of these events as triggered as an interrupt. For example, if you want timer overflow to be regarded as an interrupt, then you can configure similarly timer 1 overflow. Then other than that, serial communication. So whenever the serial buffer, that is SBUF register, is loaded with the character byte, so as soon as you load the character byte to the SBUF, serial communication begins. So how do you know that the communication, serial communication, is completed? That can be observed using the TI flag bit. So that TI flag bit can be used to monitor the interrupt. Similarly, receive also. An external event 1, external event 0 and 1 can also be used here. So these are all, we can use it as event trigger in 8051. Now in 8051 microcontroller, interrupt vector table is there. Now these vector tables we have to look into to whenever you code the interrupt service routine, this vector table plays an important role. So as we already gave an introduction to interrupt service routine, that is called as ISR. So this interrupt service routine actually contains a set of the program that is executed whenever the interrupt occurs. So how do you write and where do you write the interrupt service routine? Take an example for the first interrupt, that is external interrupt 0. So as you know that there are two external interrupt 0 and external interrupt 1. So whenever you want to write an interrupt service routine for external interrupt 0, then the interrupt vector address should be 0003. Now this 003H is a location where you supposed to have the starting instruction for your interrupt service routine. Another one is a timer interrupt 0, that is 00BH. Similarly, the third interrupt is external interrupt 1, that is 0013, timer 1 is 001B and serial port 0023. Now these are the locations that we supposed to use, and you cannot change this location because it's already fixed by the 8051 architecture. So whenever you are accessing these location, you have to be careful. When you access the timer interrupt 1, you have to write your interrupt service routine from 001B itself. You cannot write it in other location, because automatically when the interrupt comes, it will go to that location and the program start executing from that location onwards. So now you may ask, if the program length is too much, for example, if you are writing an interrupt service routine for external interrupt 0, then 0003 is the starting location. Then the code may go say 100 line code. I need to write 100 locations required. So where do you write the interrupt service routine? If you start writing from 003, it will overlap with 000B and 13 onwards. That's why 003 onwards you can have an ljump instruction and you can safely redeviate the program to a safe location. So these locations are provided to put only the minimum instruction, whereas ljump, or if a small some If you see the difference between this, hardly it is 003 to 00B, only few locations are there. You have to use those locations, either redeviate the program to a safe location and start writing the program in that location. So this is a very important vector information, that is a table that you get, and you have to use these addresses only whenever you are writing an interrupt service routine. Coming to the interrupt related registers, there are different registers that are associated with the interrupt. One is a TCON register, where you can adjust the edge or the type of the bit for the external interrupt 0 and 1. Another is SCON, where you can actually have an interrupt enable flag for the RI and TI. Another is IE register, which is an interrupt enable. So this is a very important register, IE register, where the main job is to control the entire interrupt if the IE register. Another is priority assignment, called as IP registers. All these are 8-bit registers which are used to control the interrupt. Enabling and disabling an interrupt. So how do you enable and disable interrupt? As I said already, enabling interrupt can be done only by the software. So there is an IE register which holds the enable bit for the entire interrupt. So you can mask and you can unmask the interrupts whenever required. So interrupt enable register bit description, if you see, it is a 8-bit register. You can see only 6 bits in it, starting from the MSB EA bit, that is global enable bit. So EA is a global enable bit which can disable all the interrupts. If it is set to 1, the interrupt will be enabled. All the interrupts can be enabled, the main gateway. So however, the rest of individually you can assign by setting the other bits. So but for example, if you want serial port to be enabled, plus the global enable bit has to be made 1, then only ES can be made 1. If you made global enable bit, that is the EA bit 0, then rest all interrupt, even though it is enabled, will not make any effect, because the entire interrupt is disabled. So to make any interrupt enabled, EA has to be 1, then rest of the interrupt bits like ES is serial communication, ET1 is a timer control, EX1 is external interrupt control, ET0 is timer 0, EX0 is interrupt 0, that is external interrupt. So every 6 interrupts, 5 interrupts, totally 6 including reset. So totally 5 interrupts, all the 5 interrupts you can find the bits. So when you set it, all these 5 interrupts are enabled. When you reset it, they are disabled. Here is an example how you can enable or disable an interrupt. So if you want to enable a serial interrupt or a timer 0 and external 1 interrupt, we can see how this can be done. So a question is given, show the instruction, enable, first one is enabling the serial interrupt, timer and external hardware interrupt 1. So what value should be loaded? Solution is moving the IE with hash 100101110. You have to look back to that description, bit description of the IE register, which will globally first enable the bit which is done by the MSB bit, then IE 4th bit for the serial interrupt, first bit for the and timer 0, and second bit for the enable external 1, so on. Similarly, if you want to globally disable the timer 0 interrupt only, then you can clear IE 1 bit. If you disable all, means you clear the global enable bit, that is IE 7. So this way we can individually control the global enable bit or individual interrupt bits by setting and resetting the interrupt. Priority can be adjusted in 8051. During the power on, a default priority is assigned for every interrupt. So if you look at the table, the highest to lowest priority, the external interrupt 0 is having highest priority, timer 0 is next highest priority, external interrupt 1 is a third priority, timer interrupt 1 is a fourth priority, and a serial communication is a last priority. So that means in case if all these interrupts occurs together at a time, then which will be served first? According to the table, external interrupt 0 will be served first. So this is the default status of all the interrupt priority. Now how do you change the interrupt priority if needed? So to change the sequence of a priority in an interrupt, we need to assign the IP register, that is interrupt priority registers. So to give a priority, we need to set the corresponding bit in the IP register to logic 1 that will assign the highest priority. So the IP register bit description is given here. So PX0, PT0, PX1, all these are INT0 pin, timer 0 pin, the priority. So it assigns the highest priority and the least priority. By setting any of this, for example, if you want serial communication having the last priority, if you want that to be in the first priority, you set PS1 here as 1, rest of the priority can leave it, because it will take the default table. In the default table, first priority will be given to serial communication, so that the priority will now change. So this way we can alter the priority in the interrupt for in 8051 microcontroller. So in 8051 interrupts, the important topics that to be understood is understanding the interrupts, the concept of the interrupts, the concept of the interrupt service routine, the interrupt vector table address of 8051 microcontroller, and the way to enable or disable the interrupts, that is using IE register, and finally to set the priority of all the interrupts using IP registers. Now let's see how we can write a simple interrupt for 8051 with one example. Now let's assume that this is a circuit that is used to blink an LED upon activating a switch. Now in this switch, port 0.0 is connected to one of the S1 and port 0.1 is connected to S2. But to use it as an interrupt, you need to modify the circuit. If you want this to be from the interrupt, then this has to be connected to P3.1 and 3.2. They are the interrupt pins, and the LED can be connected to any of the port pin depending on the program that you are going to write. So if you want to modify, now this is a circuit that is actually required to make a design using 8051. So if you look at this stage, so this is actually a reset part. So this part is a reset circuit which gives the logic high signal whenever you press the reset button, otherwise this will be always at logic 0. And this is a crystal oscillator section where you are going to provide 11 megahertz crystal, and then VCC and ground. Now this EA pin is made high because you are not using external memory, you are using internal memory. Now if you see, if you want to make a modification here, then this has to be connected to INT 0 and this is INT 1. So now this should be let's connect it to port 1.3. Let's connect this to P1.3. Now how the interrupt service routine is going to look. So if I am connecting the switches to INT0 and INT pin, and LED is connected to port 1.3, then the interrupt service routine should look like this. See, this is an example program that you can write if you are using an interrupt. So that will actually toggle the LED. So how exactly you can do it? So if you see here the first program, so it starts from org000 and suddenly it will go to a main program. Now this is usually done to organize the interrupt service routine, so that we can separate my interrupt service routine and a main program. So generally in the 00s routine we must have something to deviate our main program, that usually ljump main instruction. So once you do ljump main, the main program will goes to this here section. Main is given to set bit tcon 2. That is, you are actually setting the int1 into edge triggered interrupt, otherwise it will be level triggered. So if you want that action of the interrupt to happen whenever during the level or during the edge, so normally if you select level triggered, then the 0 will make the interrupt active. If you make edge triggered, then high to low transition, that is 1 to 0 transition, will make it as an interrupt, otherwise it won't be an active signal. So set bit tcon 2, that is there in the tcon register, the second bit, that you can set it to 1 to make it as edge trigger. Then IE register is the main thing. So the IE register has to be activated using 100100. So this is actually enables the external int1. You can refer to IE register once again back, and you stop the program. So that's it. So ljump will actually loop it there itself. Now you may see how the interrupt is going to come. Since we have activated the external interrupt, when the button is pressed in the previous figure, if the button is pressed, then the active low signal will come, high to low transition, that will make this program to re-deviate to this interrupt service routine, that is 0013H. So the program goes to 0013H location, and from there onwards the program executes. So now it will set the P1.3 and it will call some delay and it will clear it, and it will return from the interrupt using RETI instruction. It will come back to again sjump here instruction. So every time you activate a program at 0013 will execute and returns to the main program. So this is a simple example that can be used to write a interrupt service routine. Now in the similar way, we can also write the interrupt service routine for the timer overflow, as well as the serial communication, as well as int0, all these we can write a similar program. So only thing is that you need to write first the program at the respective service routine, and you separate your main program separately somewhere and set these interrupt priorities, or the interrupt enable type, as well as the interrupt control. So set it first using IE register, and then you can write a program in this way. So this can be tested in the lab also. So this is all about using a interrupt in 8051 microcontroller.